Welcome back, guys. This is part 2 of 8.6. So these are still the 8.6 notes. So the first part covered the double angles. This part is going to cover, this part's going to cover the half angle portion. So I wanted to split up into two parts so the video wasn't too long, because the first half was a ton of formulas, which means the second half we start with more formulas. Ugh, I know. So we're going to look at the half angles for sine alpha over 2, cosine alpha over 2, and tangent alpha over 2. So with that being said, we will start by looking at the new formula for sine squared that we made last time. So that new formula for sine squared was written as 1 minus cosine 2 theta over 2. So now we make a small substitution. We say, right above, let theta equal a over 2. So if theta equals a over 2, that substitution comes in right here. You now get sine squared of alpha over 2, which means that now all these different colors, right? So I'll put this as green. So now this portion of the formula becomes 1 minus cosine of 2 times alpha over 2 over 2. So the only replacement we had again was that this alpha also went here into the formula. Okay, so do the math, and this 2 and that 2 cancel. And that leaves me with 1 minus cosine alpha. The next thing we are going to do, let me erase all this, is after we do that, we don't want sine squared, we want sine of alpha over 2. So the next thing that happens is both sides are square rooted, which leads us to the final answer of sine alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 2. So we have a new half angle formula for sine. Sine alpha over 2 is equal to plus or minus square root 1 minus cosine alpha over 2. Okay, perfect. So let me get rid of all that. So this is our new half angle formula. Okay, now still moving. We want to do the same with cosine squared. So we start with the cosine squared formula, which we made last time. Cosine squared was 1 plus cosine 2 theta over 2. We make the alpha over 2 substitution here and there, which then, after we simplify that, you square root both sides, and we end up here. Cosine alpha over 2 is equal to plus or minus 1 plus cosine alpha over 2. Okay. So that's for cosine. The main difference between the cosine and sine is that sine is 1 minus cosine alpha. Cosine is 1 plus cosine alpha on the inside. Okay. And then tangent. Well, the formula for tangent squared was 1 minus cosine 2 theta over 1 plus cosine 2 theta. Well, of course, we make that alpha over 2 substitution again, which goes here and there. Simplify it and square root both sides. We end up at a half angle formula for tangent. Plus or minus 1 over 1 minus cosine alpha over 1 plus cosine alpha. Okay, so there you go. 3 more formulas. My goodness. I think that puts us at like 23 or something formulas. Who knows? I lost count. You probably did too. Okay, so important, the plus or minus sign represent the quadrant the half angle is in. So you will determine how to use the plus or minus signs based on the quadrant of the half angle. Okay, well, we're going to add one more formula to the mix, And it's actually an easier formula for tangent alpha over 2 for the half angle of tangent. So tangent of alpha over 2 is also equal to 1 minus cosine alpha over sine alpha, or sine alpha over 1 plus cosine alpha. And what's cool about this tangent formula for the half angle is that we don't care what quadrant the angle is, because there is no plus or minus on here. So choose either one. So, oops. So you can choose whichever one you want. No matter what, you will get an equivalent expression. They will not look the same, but they will be equivalent. And we'll get into that later. And I mean, this option looks better because it doesn't involve this mess, the square roots. So up to you which one you want to use. Okay, let's try them out. Okay. How much room? Okay, perfect. So find the exact value of cosine of 15 degrees. So once again, you look at your unit circle, you know 15 degrees is on there, but do you see a value for 15 degrees? And that answer is no. So the way we set this up is, since we're using a half angle, we are going to let, so I'm going to say let alpha over 2 equal 15 degrees. Let alpha over 2 equal 15 degrees. So now here's the important part. Where is 15 degrees located? 15 degrees is in quadrant 1. So it's in quadrant 1, right? If I drew a unit circle, here's 0, here's 90. 15 degrees would be somewhere around there. So it is important to know what quadrant your half angle is in. Okay, which means now what we're going to do is solve for alpha. So all I have to do is solve for alpha on this part, which means just multiply the right side by 2. So say let alpha over 2 equal 15 degrees, then alpha must be 30 degrees. Then alpha must be 30 degrees. Okay, so we save this information, and now we come back to what it was asking. It says, what was the cosine of 15 degrees? And since 15 degrees is in the first quadrant, we will use the positive square root of 1 plus cosine alpha over 2, because that is the formula for cosine of alpha over 2, plus or minus 1 plus cosine alpha over 2. So we're only using the plus because we're in quadrant 1, where cosine is positive. Okay. And now, there we are, which means, do we know the actual value of alpha? Alpha is 30 degrees, right? Alpha is 30 degrees, which means that this becomes the square root of 1 plus cosine of 30 degrees over 2. And now, look at your unit circle and find out what the cosine of 30 is. What is the cosine of 30? Cosine of 30 should be square root 3 over 2 over 2. Okay. So what we're going to do next is clean this up. I am going to take this 1 and convert it into a fraction. So I'll write all those steps out. So this becomes the square root of 1 over 1, 1 over 1 plus the square root of 3 over 2 over 2. Then common denominator, 2 times 2. And this becomes the square root of 2 plus the square root of 3 over 2 over 2. Now, we put this 2 in the denominator, denominator. You put this 2 over 1, and you multiply by the reciprocal. So I'm just going to show all the steps here on this one. So maybe I don't have to show the steps on the other ones. Okay. So when you multiply by the reciprocal, we get 2 plus square root 3 over 2 times 1/2. That's too big of a square root. Okay. And then this becomes the square root of 2 plus square root 3 over 4. Okay, almost there. Now separate this into 2 separate square roots. So we get 2 plus the square root of 3 over the square root of 4. And now we get our final answer. I'll just write it over here since I have the room. We get our final answer of cosine of 15 degrees is going to be the square root of 2 plus square root 3 over 2. That's it. Okay. So that's the work we have to put in. That was step by step by step. So hopefully we don't have to do it step by step anymore. So that is the process. Okay. Yes, it's ugly, but there it's done. Okay. Perfect. Let's do it again. Tangent of 7 pi over 8. So the setup is the same. So once again, I will let alpha over 2 equal 7 pi over 8. Now, where is 7 pi over 8? That's the big question. We need to know what quadrant 7 pi over 8 is in. So let's say I drew a unit circle. Here's pi, here's 0, right? 7 pi over 8. So I would say here's pi over 8. Here's 2 pi over 8. Here's 3 pi over 8. Here's 4 pi over 8. Starting to get it, because 4 pi over 8 is pi over 2. Then 5 pi over 8, 6 pi over 8, 7 pi over 8. And guess what this is? 8 pi over 8, or pi. So this means that 7 pi over 8 happens to be in quadrant 2. That is how you count radians. So this means we are in quadrant 2. Okay. Then solve for alpha. Multiply by 2. This means alpha would be 7 pi over 4. Okay, 7 pi over 4. Perfect. Now, let's come back to our problem. We have tangent of 7 pi over 8. Okay, tangent of 7 pi over 8. Okay, so we're going to use both formulas here. I'm going to show you how they work. We're going to use the complicated one first. So we will go with this one. Tangent of alpha over 2 equal to plus or minus square root 1 minus cosine alpha over 1 plus cosine alpha. Okay. And since it's in quadrant 2, tangent is negative. So you'll have the square root of 1 minus cosine alpha over 1 plus cosine alpha. Okay. And what is alpha? Alpha is 7 pi over 4. So plug it in. And here we go. Put in the work. Negative square root 1 minus cosine of 7 pi over 4 over 1 plus cosine of 7 pi over 4, which then becomes the negative square root of 1 minus, and what is the cosine of 7 pi over 4? That should be positive square root 2 over 2 over 1 plus square root 2 over 2. Okay, cool. All right, common denominators now. Put this over 1, put that over 1, get a common denominator of 2. So now this is just purely algebraic, right? So I get negative, I'm gonna make that square root big, and this should become two minus square root 2 over 2 over 2 plus square root 2 over 2. Yeehaw. Now go ahead and flip it, right? Multiply by the reciprocal of all of that. Okay. So 2 over 2 plus square root 2. Okay. Equal to the negative square root of 2 minus square root 2 over 2 times 2 over 2 plus square root 2. These 2's cancel. And we are done. Negative square root 2 minus square root 2 over 2 plus square root 2. There it is. Okay. Just terrible, right? All right. So there's that one. Now let's show it with the other formula. And I'm just going to choose this part. I can choose this part as well, but I'll just show one part of it. So I'm going to choose 1 minus cosine alpha over sine alpha. Okay. Now, method 2. So we're going to have tangent of 7 pi over 8 equal to 1 minus cosine alpha over sine alpha. And again, we know what alpha is from the above. That becomes 1 minus cosine 7 pi over 4 over the sine of 7 pi over 4. Which then becomes 1 minus square root 2 over 2 over negative square root of 2 over 2. Because sine of 7 pi over 4 is negative. Cosine of 7 pi over 4 is positive. Okay, now common denominators. Put this 1 over 1. And I'll get 2 minus square root 2 over 2 over negative square root 2 over 2. All right. Then multiply by the reciprocal. 2 minus square root 2 over 2 times negative 2 over the square root of 2. All right. Cancel, cancel. And what am I left with? That negative will change everything. So this negative will make the numerator square root of 2 positive and the 2 negative. So this is what I'm left with. So I get square root 2 minus 2 over the square root of 2. All right. Yeah, it's positive square root of 2 minus 2 over the square root of 2. Sounds good. Okay, but now, of course, we can't leave it like this. So I rationalize. And you get, so if we distribute that, I'll get square root 2. No, I won't get square root 2. I'll get, so square root of 2 times square root of 2 is just 2 minus 2 square root 2 over that square root of 2 times that square root of 2 is also 2. Whew, buddy, almost there. Then I see that I can reduce everything by 2. So this becomes 1 minus square root 2. Now the question is, how are these the same answer? Oh boy. Well, There's only one way to figure it out. So you're going to watch this, okay? Since we have all the time in the world, I'm going to put them equal to each other. Since they are supposed to be the same, I'm going to make them equivalent to each other. So here's what's going to happen. And I'll erase it. Or I can leave that on there. You probably won't be able to print it out, though. But it'll be there. So I'm going to make 1 minus the square root of 2 equal to the negative square root of 2 minus square root 2 over 2 plus square root 2. Is that good? Yes. Okay. So now we want to show that these are equal. So the first thing I'm going to do is get rid of the square root on the right side. So the first step is square root, not square root, square both sides. So you'll get 1 minus square root 2 times 1 minus square root 2. Equal to, well, when you square the right side, it becomes positive and the square root is gone. So I get 2 minus square root 2 over 2 plus square root 2. All right, let's go ahead and clean up the left side. We'll FOIL that side. So that'll give me 1 minus 2 square root 2 plus 2. Okay, perfect. 1 minus 2 square root 2 plus 2, because that's 1, that's negative, so that makes 2, and that makes positive 2. Okay. Equal to the same thing over here, 2 square root 2 over 2 plus square root 2. Okay. And then this becomes, what do I get? 1 and 3, so I get 3 minus 2 square root 2. So that's what the left side has become. Okay, well, now we need to clean up the right side. So this is kind of like proving an identity, right? Well, almost like an identity. So what could I do here? Yeah, let me see. Yeah, since I squared both sides, yeah, this is kind of open game. So what I'm going to do is take this denominator and multiply it to the left side. So if I do that, I'll get 2 plus square root of 2 times 3 minus 2 square root of 2 equal to 2 minus square root 2. Then I'll FOIL this out, and I'll get 6 minus, what's that? 4 square root 2 plus 3 square root 2 minus 2 times 2 equal to 2 minus the square root of 2. Now clean this up and I get 6 minus 1 square root 2 minus 4 equal to 2 minus the square root of 2. And one more cleanup, and look at what we have. 2 minus square root 2 equal to 2 minus square root 2. Thus proving that these two solutions are definitely equivalent. But that's the work we have to go through. Yeehaw. Okay, what will I put? Proof of equivalence. proof of equivalence. Perfect. Okay, cool. Do you have to do that? No, but this is to show you that you get equivalent answers that look different, okay? All right. Let's keep moving. Let's keep working these the same. What am I at? Okay, right there. Find the exact value of the sine of 195. So again, let alpha over 2 equal 195 degrees. Now, what quadrant is 195 in? Well, here's 180. There's 270. So 195 has to be in quadrant 3. Okay. So this is in quadrant 3. Okay. Then solve for alpha. Multiply the 2 to the right side, and 195 times 2 is 390. (390 degrees). Okay, now we know the value of alpha. So sine of 195 degrees will be equal to, and since we're in quadrant 3, sine is negative. So this would be the negative square root of 1 minus cosine alpha over 2. 1 minus cosine alpha over 2. All right. So one time my friend, he spun out in his car, and he gets out and he's like, man, did you see that? I did a total 390. And I was like, oh, so you did a 360 plus 30 degrees. That's cool. He was like, what? So, funny story. Let's keep moving. Did I say 360 plus 30 degrees, right? Whatever. All right, let's keep moving. So, and you get the negative square root of 1 minus cosine of 390 degrees over 2. All right. Now, what is the cosine of 390 degrees, right? Cosine of 390 degrees. Well, we can think coterminal, right? So 390 is over a revolution, right? So the cosine of 390 minus 360 is going to give us the cosine of 30 degrees. Like I said, like I told my friend, you did a 360 plus an additional 30 degrees. So you're at the cosine of 30 again. Okay, keep moving. And you get out the negative square root of 1 minus, and the cosine of 30 degrees is again square root 3 over 2 all over 2. Okay. Now again, common denominators. You get the negative square root of 2 minus square root 3 over 2 all over 2. Then multiply by the reciprocal. And we get the negative square root of 2 minus the square root of 3 over 2 times 1/2. Which again gives me the negative square root of 2 minus square root 3 over 4 which gives me the negative square root of 2 minus square root 3 all over 2. That's it. That is the sine of 195. Yep. Okay. All right, the cosecant of 7 pi over 8. Oof. All right, so this will be fun. All right, so like all the other ones, let alpha over 2 equal 7 pi over 8. And from one of the previous examples, we learned that 7 pi over 8 was in quadrant 2. Then alpha must be 7 pi over 4. Okay, let's do this. So we don't have a half angle formula for cosecant, but we have a half angle for its reciprocal function, sine. So this means that we will write cosecant of 7 pi over 8 is also the same as 1 over the sine of 7 pi over 8. Now let's keep expanding. You'll get 1, not 7 pi over 8. That should be, no, yeah, that's 7 pi over 8. So, and in quadrant 2, sine is positive. So we're going to get 1 over the square root of 1 minus sine alpha over 2. Not sine alpha, cosine alpha. Ha. Cosine alpha over 2. Okay. And we're using the positive one because we're in quadrant 2. So we know what alpha is, but before I plug anything in, let's go ahead and fix this up algebraically because it already looks like a mess, right? So what we're going to do is make this 1 over, and I'm going to take the square root and split it into 2. Square root 1 minus cosine alpha over the square root of 2. Which means that you will then reciprocate this part. Reciprocate that part. So what we get now is square root 2 over square root 2 over the square root of 1 minus cosine alpha. And now you can put it back as the square root of 2 over 1 minus 1 minus cosine alpha. So what we can say to make life easier, in case you ever come across this, is that this is now a half angle formula for cosecant. Why does it keep doing that? Of alpha over 2. Okay, and the same could be said for secant. It would just be 1 plus cosine alpha. So 2 over 1 plus cosine alpha. Okay, so back to the beginning. So this means that we now get cosecant of 7 pi over 8 is going to equal the square root of 2 over 1 minus cosine 7 pi over 4. Now let's keep going. You get the square root of 2 over 1 minus, and cosine of 7 pi over 4 is positive square root 2 over 2. And then common denominators, 2 over 2 minus square root 2 over 2. All right. And then reciprocate square root of 2 over 1 times 2 over 2 minus square root 2. Okay. And what we are left with is oops, not blue. The square root of 4 over 2 minus square root 2, which then becomes 2 over the square root of 2 minus square root 2. There it is, in all its glory. Sure, if you want to try and rationalize it, try and rationalize it. Have fun. But I believe we can leave our answer as this. But if you did try to rationalize it, I'm not going to do it. I think you would have to multiply by square root 2 plus square root 2 over square root 2 plus square root 2. Yeah. And I still don't think that gets rid of the, maybe it gets rid of the radical. But if you were to conjugate, that's what you would multiply by. Okay. Not bad. All right. So that's how we handle those types of problems. Now we are going to come across these type of problems. Find the exact values using half angle formulas for cosine alpha equals -3/5 if alpha is stuck between pi and 3 pi over 2. So find sine of alpha over 2, cosine alpha over 2, and tangent alpha over 2. Okay, so before we even begin, so this is, they're giving us the location of alpha. Before we even begin, we need to find the location of alpha over 2. So this is what we're going to start with. Find alpha over 2. So what I'm going to do is I'm going to draw my unit circle. So there's 0, there's pi over 2, there's pi, and there's 3 pi over 2. So what they're giving us right now is that alpha is stuck between pi and 3 pi over 2. So alpha is in here in quadrant 3. So that's what we'll draw. So here is alpha. Okay, so here's alpha. And over here is the ratio for alpha. So cosine of alpha is -3/5. this means that the base of my triangle should be -3. The hypotenuse should be 5, and our height should be 4, 3, 4, 5. So here's going to be -4. Okay, so this is everything for alpha. I said we need to find alpha over 2, and the way we're going to do that is take the restrictions given above. So I'm going to rewrite the restrictions that are given above. Pi less than alpha less than 3 pi over 2. And the way to find the location of alpha over 2 is to take these restrictions and divide them by 2. Divide these by 2. So this means that our half angle is going to be stuck between pi over 2 and 3 pi over 4. This is the location of alpha over 2, which means related back to our unit circle, and we're stuck between pi over 2 and 3 pi over 4. So there's pi over 2 above, and 3 pi over 4 would be in quadrant 2. So here's 3 pi over 4. This means that our half angle is stuck right here. So our half angle happens to be in quadrant 2. So we can say location of alpha over 2 is quadrant 2. Location of alpha over 2 is in quadrant 2. And the reason we do this is so we know what appropriate sign to use with the correct half angle formulas. Okay, so let's get started. And we want to know, what is the sine of alpha over 2? Well, by the formula, we know sine of alpha over 2 is, and since we're in quadrant 2, it's going to be the positive square root of 1 minus cosine alpha over 2. Which then means we get the square root of 1 minus, and what is the cosine of alpha given here? Look, it's right above. Cosine of alpha is -3/5. So that's what we plug in for cosine alpha. So I get minus -3/5 all over 2. Cleanup time. The pre-cal is done. The trig is done. Now the rest is just algebra. Clean it up. So we get the square root of 1 plus 3/5 over 2. Common denominator now. I'll move over. Put that 1 over 1, get a common denominator of 5. And we will get the square root of, I don't think it needs to be that big. We'll get the square root of, when you combine it, it should be 8 over 5 over 2. Okay, now multiply by the reciprocal, and you'll get 8/5 times 1/2. And then that becomes the square root of 4 over 5. Yeah, we're good. Which becomes 2 over square root 5. But can we leave it like that? No. So our final answer is 2 root 5 over 5. There you go. That's how you work it. Okay. And then let's do it again for cosine alpha over 2. All right. Cosine alpha over 2. Well, since our half angle is in quadrant 2, cosine will be negative. So we'll have the negative square root of 1 plus cosine alpha over 2. And again, from the above, cosine alpha is a negative 3/5. So 1 plus negative 3/5 over 2. And you get negative square root of 1 minus 3/5 over 2. Common denominators. And you should get the negative square root of, what do I have? 1 minus 3/5, so that should be 2/5, right? You get 2/5 over 2. Multiply by the reciprocal. 2/5 times 1/2. And you get negative square root of 1/5. Which becomes negative 1 over square root 5, or negative square root 5 over 5. There it is. Okay. Perfect. All right. So now we get to tangent over 2, alpha over 2. Okay. So we can choose from actually 3 formulas, right? Remember that tangent can be, and since it's in quadrant 2, it'll be the negative 1 minus cosine alpha over 1 plus cosine alpha. Or we can use the other formula, 1 minus cosine alpha over sine alpha. Or we use the other formula, which I think is sine alpha over 1 plus cosine alpha. So you get 3 formulas to choose from. I'm going to tell you a secret. Don't choose any of them. I'm going to make your life really easy because I'm going to do this by identities. You're like, oh, great identities. Why can't I just use the formula, right? Well, what I mean is that tangent becomes sine of alpha over 2 over cosine of alpha over 2. And wouldn't you know it that, do we have a sine of alpha over 2? We do. It's 2 square root 5 over 5. Do we have a cosine of alpha over 2? We do. It's negative square root 5 over 5. Use those values. Work is so much easier now, right? So that's 2 square root 5 over 5. So this becomes 2 square root 5 over 5 over negative square root 5 over 5. Right? Is that what I have from the above? Yes. Fraction over fraction. Multiply by the reciprocal. Cancel, 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 cancel. And we get left with negative 2, which would be the same answer if you chose any of those 3 complicated formulas. So that was nice, huh? Okay. Boom. So that's how you solve these ones. First thing you need to do is find the location of alpha over 2. And the reason we need that location is because it tells us what sign we should use on the half-angle formula. Okay. All right. Cool. All right. Now back to these types of problems. These are the substitution problems. Find the exact value of each expression. Okay. So we are going to be using double angles and half angles for this. So to solve these, we need to make a quick substitution. So I'm going to say, let theta equal the inverse sine of the square root of 3 over 2. So let theta equal the inverse sine of the square root of 3 over 2. Why don't I include the 2 in there? Because it makes it more complicated. If I just make it the inverse sine function, well, this means that when I bring the substitution back in, this becomes just the sine of 2 theta, which means that we can use the double angle formula for sine on it. So doing this makes the work a lot easier and less complicated. So let's continue, because now we have some stuff to figure out. All right. Then apply the inverse to both sides, compose both sides, and you get sine theta. Oops. Sine theta equals square root 3 over 2 on the inverses restrictions, negative pi over 2 to pi over 2. Which means we draw our little unit circle. There's negative pi over 2. There's pi over 2. And if square root of 3 over 2 is positive, this means we must be in quadrant 1. There's my theta. And if sine is square root of 3 over 2, sine puts opposite over hypotenuse. And by Pythagorean theorem, you'd get 4 minus 3, so the base is 1. Okay. We are now ready, and we're going to bring back our substitution that I wrote above, right there, sine 2 theta, which means that down here, I'll say sine of 2 theta, which by the double angle formula for sine is 2 sine theta cosine theta. And all we have to do now is reference the triangle above. All right, so this becomes 2 times, what's the sine of theta given? Square root 3 over 2. What's the cosine of theta by that triangle? Cosine of theta is 1/2. And you'll get what? If I multiply straight across, 2 square root 3 over 4, or also square root 3 over 2. Okay, not bad. All right. Do it again. Same thing. Cosine of 2 cosine inverse of 4/5. Let theta equal the inverse cosine of 4/5. Then cosine theta is 4/5 on cosine's restrictions. Zero to pi. Draw my little unit circle. There's 0. There's pi. If cosine is positive 4/5, we again must be in quadrant 1. So there's theta. Cosine puts adjacent over hypotenuse, which means this must be a height of 3. Okay. Bring back our substitution. And this becomes cosine 2 theta. Right? So this becomes cosine 2 theta. Okay, so cosine 2 theta, we have 3 formulas to choose from. Cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. Ugh, all these formulas. I'm going to choose the one I like best, which is cosine squared theta minus sine squared theta. Choose another formula to see how we get the same answer. Okay? I hope we get the same answer. Okay, so all this means is, what is the value of cosine theta? That is 4/5, and you're going to square it. Minus, what is the sine of theta? That's 3/5, and you're going to square it. Okay. Which means we get 16/25, right? Minus 9/5, which will give me 7/5. Fifths, not fifths, 25ths. 7/25. There you go. That's it. That's ugly. 7/25. And that's how we do that. We've done these type of substitution problems before. We're just now applying new formulas to it. Okay. Last two. Oh my goodness. Okay. All right. Again, theta is the substitution here. Okay. Theta is the substitution. Was that the last one? Okay, yeah. Okay. Okay. So this would be theta. So again, let theta equal the inverse tangent of negative 4/3, then tangent theta is equal to negative 4/3 on the inverse restrictions of negative pi over 2 to pi over 2. Draw our unit circle. And theirs is negative pi over 2, pi over 2. And if tangent's negative, this means we must be down in the fourth quadrant. Okay, and tangent puts opposite, so negative 4 over adjacent, which means the hypotenuse must be 5. Okay, now let's bring back our substitution, because that becomes cosine 2 theta. Cosine 2 theta. So cosine 2 theta. And let's go ahead and switch it up. I'll choose a different one. I'll choose 2 cosine squared theta minus 1, which means you get 2 times the value of cosine here, which is 3/5 squared minus 1, which means we get 2 times 9/25 minus 1, which gives me 18/25 minus 1. Oops. Which means common denominator, 18/25 minus 25 over 25, and we'll get negative 7/25. Okay, perfect. All right, cool. And same thing you would get if you chose the other two formulas for cosine 2 theta. What would that be? 3/5, so 9/25 minus 16/25. So yeah, negative 7/25. Okay, last one. Same thing. I'm going to say let theta equal that, right? So let theta equal the inverse sine of 3/5, then sine theta equals 3/5 on negative pi over 2 to pi over 2. Unit circle. And since sine is a positive 3/5, this means we are in quadrant 1. And sine puts opposite over hypotenuse, so this means that has to be 4. Okay. Bring back our substitution, because that became cosine squared of 1/2 theta, or cosine squared of theta over 2. So that's where we'll start. So we get cosine squared of theta over 2, which means we're going to use a half-angle formula, somewhat of a half-angle formula. The only difference here is that this is squared. For half-angle formulas, it's cosine of theta over 2, not cosine squared. So we're going to have to take a peek back at our half-angle formulas. So let's see. Cosine squared, all right. So we're looking at here, that's cosine squared of theta. So this one says cosine squared of theta. We want cosine squared of theta over 2, which happens to look like this one. Theta, alpha, beta, whatever, they're all terms of angles, right? So cosine squared alpha over 2. So that's what we're looking for. This means that we are going to use this formula then. So, I mean, you can cancel out the 2's already. So what we're going to use is the formula 1 plus cosine alpha over 2. That's what we're going to use. Okay. So 1 plus cosine alpha over 2. Let's go back. Oh, there we go. So you'll get 1 plus cosine theta over 2. Perfect. And then all we have to know is what's the value of cosine. And cosine from this triangle, uh-oh. Did it freeze? I think it froze. One moment, please. Uh-oh. What's it say? What's it say? Connecting. Boo. I'm going to pause for a second while I fix this. All right, fixed it. Okay, so like I said, we were using that formula 1 plus cosine theta over 2. So we bring that in, and now all we have to know is what is the value of cosine at this value of theta. So we reference the triangle, and cosine theta is going to be 4/5. So 4/5 over 2. Common denominator in the numerator, that'd be 5/5 plus 4/5, so 9/5 over 2. Make that into 2 over 1. Multiply by the reciprocal. 9/5 times 1/2, and our answer is 9/10. That's it. No need to square root it. It doesn't want it. It wants cosine squared, not cosine theta over 2. Whew. All right. So there it is. Those are half angles. That finishes 8.6, which means we can now move on to 9.2, I think, law of sines. Okay, that is it.